Hi students, you are welcome once again to Mostly Academy Online UTME and SSC exam prep. Today is the day 28 of our countdown to all the phases topics, and we are now into what we call the modern physics. I call this part 1 of the modern physics. Here in the first part, I am only going to cover the atomic structure and the nuclear physics part. So like I said, modern physics video is going to be in 2 categories, if not more than 2, because I don't want to leave anything uncovered, because most of your schools and tutorial center do not say this. Most of you don't have a good idea about this aspect of physics. So the modern physics might be 2 or 3 depending on the way I see it, or depending on the way the Mostly Academy team is preparing the question. So this first one covers only atomic structures and the nuclear physics. The other one will cover what we call your photoelectric effect and X-ray. Maybe the third one will cover radioactivities, half-life, and other things you need to know with respect to applications and the rest. So now I'm going to talk basically on atomic structure and nuclear physics. Here we are going to introduce ourselves to the structure of an atom, which is more like your chemistry, which I believe you have 1 or 2 ideas. But here we are only going to limit ourselves with what is needed in the physics way and only the questions that is going to be asked. Now let's start with the topic, and if you find anything interesting, please consider subscribing to this channel and tell your friend about it, because there is where you can do quick revision for your WAEC, SSC, or the JAMB UTME examination. Let's kick started. Now, the first thing is an important experiment evidence for the existence of levels in the atom is the existence of quantized energy dash. Now, before we understand this, let me quickly introduce us to what we call, I think I need to reduce this, the origin of the atomic structure or structure of an atom. Now, in physics, we focus more on three major scientists, which you might have studied before also in your junior classes, and if not, I'm here to make sure you all get this, because it is very, very important. The first one is J.J. Thomson. That is Thomson experiment. Excuse me. Then we'll talk about Rutherford experiment. And the last one, which was the most successful of its time, is Bohr hypothesis or Bohr's experiment. Or we call it Bohr's postulate, the way it is being called in junior classes. Now, to understand this, we just need to talk a little bit on them, just because this is the most important one, to be honest. Now, J.J. Thomson is more like telling us about the distribution, or talking about the nature or composition of an atom. That is, atom is spherical. Atom is spherical and is surrounded by what? By positive charge. In which atom is spherical and surrounded by, like I said, surrounded by uniformly distributed positive charge. More like the plum, but just like your watermelon. You know the way watermelon is being separated. That was the way this man actually was positive or charge. So later in the year, he was given the accolade, or he was given the name. He later discovered what we call electron in 1879, to be precise. Electron was discovered by this J.J. Thomson in 1879, to be precise. That is all about his own experiment and hypothesis. Now, the next person I'll quickly talk about is Rutherford. Now, Rutherford was given the accolade of discovering what we call proton, but his experiment was more like what you call the alpha scattering experiment. I hope you have studied that also in your junior classes. The alpha scattering experiment. by where we actually use a gold foil chemistry way, but here we are limiting ourselves because this is physics and we only need to focus on what is important under this stuff. So here we are only talking about I said alpha scattering experiment, which led to the discovery of what we call the protons. Protons was discovered later in according to this experiment was discovered CORED, I think in 1931 to be precise. I'm a teacher of chemistry. For those who don't know, I teach chemistry a lot. Now, this experiment was actually based on alpha scattering experiment, and it was more like talking about the central, that is the nucleus. The experiment you can also write, I think this is lagging. It's more like talking about the concentration or the revolving of electron around, I think this should be back. Yes, yeah. So we talk about more of the distribution of electron and the circulation of electron around the particular nucleus. So he was able to discover that nucleus is positively charged and electrons revolve around it. Now, the problem about Rutherford around it. Now, the problem about him, he was unable to tell us the location and the position of the electron that revolve around the nucleus. So the combination of J.J. Thomson, actually later in 1931 he discovered the proton, and that calculate was given to him. Now, you can remember the anode and the cathode ray experiment in your chemistry. Now, if you don't know about that, I think, like I said, I'm still going to make the chemistry channel. I'm going to do all the concept of chemistry for SSC and WAEC level for you to actually have a good and deep knowledge. These I'm going to cover in my chemistry concept. Don't worry. So let's limit ourselves because of time frame and other things. Then the most important one, which I told you it was the most successful, was Niels Bohr, according to the way we call it. Now you can ask me, who now discovered neutron? The discovery of neutron was actually given to a man called James Chadwick. Maybe I should just tell you about that, because there are still a lot of names. James Chadwick discovered neutron because neutron. So keep that at the back of your mind. And we were told that in the combination of an atom, the electron exists outside. That is nuclear physics, whereby the proton and the neutron are found inside. So later we are still going to talk about that. Don't worry. Let's take it together now. About the most successful one, which I call of his time, with major postulates, in fact, are divided into three, which I think students should know. Bohr's postulate, the way it is being called, postulate of Niels Bohr, N-E-I-L, that is his full name. So the first one was talking about, we talk about electrons revolving around what an elliptical orbit, the way it is being said. Now the electrons are revolving. Now he was able to tell us the position of electron and the charge. Electron is negatively charged. I hope students actually knows this. Later the charge of electron was also discovered by a man called, it's a popular one. The man was oil drop experiment, chemistry way, atomic structure is chemistry way. This man was called, I think, R.A. Millikan, yes, to be precise. He was the one that discovered the charge of electron, which is basically 1.69, I think 1.6 times 10 raised to minus 19, not 1.69, 1.6 meet times 10 raised to minus 19 coulombs. So now all these are, I think the charge was discovered by a man called R.A. Millikan. You can always keep names at the back of your mind, because you can never say what examiner based on experience. That is what I'm using to talk. I am talking based on experience. All these are very, very important. So R.A. Millikan, from what they call the oil drop experiment, popular in chemistry, but in physics we focus on these three under our structure of an atom. So Bohr hypothesis was basically on three things. Like I said, the revolving, the circulation of electron around the nucleus. So circulation, the first one was talking about circulation of electron around the nucleus. So it was the only successful his experiment was the only successful experiment of its time as at that time, but it was still a postulate because it was based on the experiment. The mathematical interpretation was not proven by him, and this is very simple. If I am not in concept video class, I am here to solve questions, but because I want to solve questions, I need to give you an idea about every other thing you can see under this topic because it is needed. Now, like I said, because of that, he was able to explain that. Maybe I should draw that as this guy, just watch, as this guy electron revolve. That was what this guy was unable to talk about. So he let us understand that we have the mass of an electron, or let's say the radius, the neutron. It is revolving like the nucleus. The radius of the nucleus, I write as Rn. The electron is basically, and it's revolving. There will be a velocity, just like circular motion we have talked about. This is not needed to be honest. I'll write that one as Vn. That is the velocity of the nucleus in which it is revolving around. Then the electron is E minus. Then the charge of electron is written in what in physics as Ze. Please, this is called the charge of the nucleus. Charge of the nucleus. I hope students are here. So now, as this guy, from your electrostatic force, the force will be generated, which we call nuclear force. We're still going to talk about that because there is a stable kind of force. Nuclear force are just short-range forces. And I'm doing classification of forces. I've talked about that. From here, we can use Coulomb's law, Q1, Q2 divided by R squared. But for this, it will be now, you can see our Q1, Q2 is what? The charge of this one, which we write as Ze squared over Rn squared. So now this particular force, we balance the centripetal force, and that was his first hypothesis, his first postulate. So he said KZE squared. I'm taking this for those who are actually doing JUPEB or any other type of exam too, is now equals to centripetal force is mv squared over r. So we have m vn squared by r, mv squared by r. So this gets cancelled out, cancel this square, this is Rn. So the first hypothesis was basically mvn squared is equals to kze squared. So this was what he was talking about in the first one, in the first postulate of Bohr, which you need to keep in mind. Now the second and third postulate are also very important, and on doing that, my dear student, I am going to clean up some spaces here for you to understand. The second was actually talking about angular momentum. Now, still about the revolving of the circulation. So the second postulate of Bohr, you have to keep this Bohr experiment at the back of your mind. It is the most important experiment and the most successful of its time. This I'm going to cover all the modern physics aspects for your level. Don't worry, I promise that. The second video will talk about those ones you are waiting for. Talking about your S-ray and your work function and photoelectric emission. Don't worry, I'm going to cover that. But this one, we cannot just say we want to jump into that without talking about the first part, which is the atomic structure and the nuclear physics aspect. Now, in continuation to what I'm saying, the second postulate of Bohr, I am talking about Bohr postulate, and we have noticed that our electron revolve near the nucleus. Now, it was now able to tell us that the position of this electron can only revolve near a stable nucleus. For example, it is not that the electron will revolve near the nucleus. It is only when it is in a stable orbit. So, which is what this question is asking you. So, electron revolves around a stable orbit, called, please, energy levels. Now, and this is where you're going now. About this one, he was only able to explain to us in terms of angular momentum. We've talked about that before. Angular momentum is mvr. He said it is equals to n open bracket h over 2 pi. This is very important. Now, where n means n is just a set of integers. That is the level of what. That means each of these revolving of what, of electrons around nucleus must always be in a stable orbit. This stable orbit is called what? Energy levels. And this is one of the most important aspects you need to talk about. You can see me, I'm actually talking about concepts. but it is needed for you to actually answer this question in the remaining minutes. Now, a quick one, like I said, how he was not able to prove mathematically about how this, but he said this is a constant h over 2 pi in which what n stands for what different levels of energy. Now, about Bohr hypothesis, you also need to keep in mind. I am rushing. I am very sorry. I am rushing you guys. Now that it is only applicable for hydrogenic atom. When I say hydrogenic atom, that is, it is not about for one electron atom. So basically we use hydrogenic. When I say hydrogenic, for hydrogenic atom, that is H. Or sometimes if somebody writes helium plus, I hope students remember this in their chemistry. It's also possible because this is what helium is 2. You understand what I mean? Helium plus, so like three charge of helium. You understand what it means. So, but mostly we use it for what H plus atom. So that is what is the limitation of what this man postulate. So now it was later the mathematical. He was unable to prove to us mathematically how he come about this. But later, when a man called the Broglie's hypothesis, which I am still going to cover under the concept of photoelectric emission and thermonic emission. I am sorry, I am rushing. I am going to talk about this. So for now, he was able to. It was now that man called the Broglie's. He was able to explain to us that the wavelength of this particular orbit is now equals to h over the angular momentum equal. So these I'm going to cover later, don't worry. But for now, keep this at the back of your mind. So it was from this, was able to let us that each of these particular things we are talking about are actually moving with respect to the angular momentum is proportional to the constant he called h over 2 pi. Like I told you, he was unable to prove this, but it was later proven by a man called the Broglie's. You might have heard about it. I'm sure you've heard about it. And he was the one that explained this to us in terms of circumference of a circle is 2 pi r. And if circumference is equals to 2 pi r, it must be equals to what? The number of the energy level multiplied by the wavelength of this. So you can see from here, you can substitute, you are going to get this formula. I am not here to prove or to show you I can prove formulas. I'm here to tell you straightforward and to be concise in what I am writing. So please keep that at the back of your mind. And that is that about that. Now, the third postulate, because I told you it is 3 postulates of NECO. The third postulate, which you also need to keep in mind, please you keep a note. It's very important. When I'm teaching, you have to write down something very, very important. Now, the third one, now we know that what each of them are actually in a particular orbit called energy levels. Now, the third one was not able to tell us that what. Now, the electrons, let's write electron transition, that is transit, they move from one point to another. That's what I call transition. Electron transition, I hope my spelling is correct. Transition, electron transition between energy levels. So he was able to talk about the transition of electron between different energy levels. For example, a quick one, let me draw a line for you because this is also one of the most important aspects also, like I said. Now, he talked about different energy levels. I think I need to use a red. Already guys, I'm rushing. So now, we talk about that electron revolve around a stable orbit. So it's not that it just revolve, it must be a stable orbit. And he gave a constant of angular momentum equals to n equals to h over 2 pi, where n is set of number, natural number. So different energy levels are now represented in terms of what? Like I said, only applicable for hydrogenic atom, important point. Then you now have different energy levels, which I am just trying to show here, because you need to understand. Then the energy level of each of them was also given in formula. You just need to keep the 3 formulas of his hypothesis at the back of your mind. Just for the sake of time, because of time. I have not even answered any question. So let me just tell you about it now. If what we have different energy level from a number of let's say n equals to 0 here, we have n equals to 1, n equals to 2, n equals to 3. So this is what n stands for, set of real numbers. So set of integers. As you are going up, the lines become what? They become what? Closer to each other. That's just the fact. I'm not drawing to scale now. So here we can say n equals to 4, then the next one will be what? Till n equals to what? Infinity. So the transition of what? Now, when energy is being supplied, energy is supplied in two ways. Now, there are two ways in which energy is supplied. Shorty concept. The first one is by photons, which is what you need to keep in mind, and the second one is by collisions. Now, if energy is supplied, they now transit from one energy level to another energy level. So this was what we are talking about. So the transition from one point to another, it's going to release energy. It can also move from higher energy level to lower energy level. For definition's sake, we define in terms of excitation energy. I'm taking classes, imagine, and ionization energy. Ionization energy. This ionization energy, I hope students that you study that in your chemistry concept. Now, excitation energy is just telling you from lower energy level, the energy transit means movement, from lower energy level to higher. So each of them has a particular energy we measure in what electron volts. Now, this was now also given mathematically. You know, all these has formulas, like you can see, the first formula for the first postulate, the second formula for the second postulate, then the third formula, which is the most important one, was now the energy that is being liberated in form of photons is now given as E is equals to HF, which is also the same thing as HC, or let's say delta E, because they are moving from one energy level to another. H is the same thing as HC by lambda. It's always keep this at the back of your mind. This is the energy that is being what? Transit from one energy level to another. So if it is moving from lower energy to higher energy level, it is said what the energy required for movement is called what? Excitation energy. To remove an electron or to move from one point to another, from lower to higher excitation. Whereby ionization can be from any state to what? To n equals to infinity. So it can transit from 1 to or from 0 to infinity. The 0 here in chemistry, you guys are used to that, you call ground state. Please keep it in mind. These are short, and the highest point is called excited state or excited state, anyhow you call it. So just keep it in mind. So this particular energy is the third postulate of NECO, and this formula also is very, very important for you to keep. So they now form, as they are moving from one point to another, they form the kind of line we call what? The spectral lines. So these lines are the spectral lines, and this is what we are talking about here. So keep it in mind. A lot of formula can be given there because at each energy level we have, for example, lowest energy level here, we say it's 13.6 electron volts. So it will be given. So if something is moving from 1 to 2, it will be E1 minus E2. So please just say the lower minus the higher. If it's moving from 2 to 1, it will be E2 minus E1. Student, please keep this in mind. Time is not on my side. I have to rush it. A lot of formula can, like if you want to calculate the wavelength of energy level, we use the right back constant, which I think you might have studied, but for A-level student, for a level, I don't think it's important. And if you want to know more about it, like I said, concept video are always available. Please always keep that at the back of your mind. So as energy are moving from one point to another, we can define what we call the energy in each energy level, in each of the energy of electron in each orbit, in each of the orbits. The energy is now given by, you can keep this one in mind, is important. Energy in each orbit is given as, please, negative 13.6 multiplied by multiplied by the atomic number divided by n squared. This formula, please keep it at the back of your mind because it's also important for your level. So this is energy. For example, if I want to get Z is atomic number at this one, when n equals to 1, you can say 1. When n is 1 squared is 1, Z is for what? You know what's the atomic number for hydrogen, like I told you. It is only applicable for hydrogenous what? Atom, hydrogenic atom, the way we call it. So guys, that is all about this for now. So let's focus on the question. From the question, we'll still talk more about other things you need to know. So the first question answer: an important experimental evidence for the existence of energy level in an atom is the existence of quantized energy of what? Spectral lines. So that is what proves to us that what each energy or energy electron transit from one point to another when they move from ground to excited state. Please also note that what lower energy is more stable than what higher one. As in lower is more stable, that is n equals to 1 is more stable than n equals to 4. Please keep that at the back of your mind. So the answer to this, guys, is what? Spectral lines, and that is what the way with what we teach, because here we focus on what you need to know and not talking about what. You can see what I've done. I've actually taken almost everything you need to know about this what introduction to atomic concept based on the concept of what modern physics in your syllabus. because there are still a lot of things, to be honest, I can still talk about. Now, the next is that the following statement relates to atomic spectrum. 1. All elements emit and absorb characteristic spectra. We talk about that, correct? Spectral analysis is an important method to identify environmental pollution. Is rubbish, doesn't have anything to do with it. The chemical composition of stars could be determined using the spectra. You can see how stars appear, you know that. So this is also very correct. So we can go for the answer. 1 and 3 is correct here. From explanation, I think I can continue to pick answer. So we move to the next slide. Let's move. Fine. The nucleon number and the proton number of a neutral atom is 238 and 92. What is the numbers of neutrons there? Now let's quickly talk about this. I hope you have also studied this in your junior classes, and if not, you can always take it. Now for nuclear physics, we talk about the amount of energy that is required to form a nucleus is called binding energy. Keep it in mind, also very, very important. This thing is lagging yet again, but I'll quickly talk about what I want to talk about. The amount of energy required to form a nucleus is called binding energy. Now, yes, I take it back. Binding energy. Energy required to form what? The production of nucleus. So energy that is lost during that process. Now, basically, if you have X as an atom, having atomic number, atomic mass of A, atomic number of Z, keep it in mind. This is called numbers of protons. Z is called number of protons or atomic number. You keep this at the back of your mind. A is called mass number, which I believe most of you, or numbers of nucleons. Numbers of nucleons is defined as proton plus neutron is equals to mass number, which is also called nucleons. So numbers of nucleons, keep it in mind. Now we now say A minus Z is the numbers of neutrons. So I think you have studied this also in your junior classes. So we now state that the nucleon number and the proton number of a neutral atom of an element are 238. This is 238 and this is 92. The number of neutrons will now be A minus Z. Direct question. So 238 minus 92 will give you the answer. I think 146. 146 plus 92. No, 119 plus 32. Just looking at 238 minus 92. That is 146. So this is the answer, guys. And that is that about that. So I see to talk about how to calculate what we call the binding energy in atomic mass unit and all that thing, but because of time, I will still talk about that as we move forward. Which of the following statements are true about the structure of atom? I've talked a lot about it. Let's see if we can answer. The atom of different elements differs only in the number of protons and electrons. B, the number of protons is equal to the number of electrons. So please, this is a statement under nuclear physics. Number of protons is the same thing as what number of electrons. Very correct. Atoms are constructed according to the plan of our solar system. This is also correct. You can see what I'm now again. The atom of energy differs only in number of protons and electrons. Number of protons is equals to number of electrons. So the answer is A and C. So please note that the numbers of protons, this first statement is wrong. The second statement is correct. The number of protons is equals to the number of electrons. Very correct. Let's check it. Atoms are constructed according. C is also correct. Then the atom of different elements differs only in the numbers of protons and electrons. They also differs in number. This is wrong. So I think there's a mistake here because the answer to this question should be B and C. Please note that not A and C. B and C. Maybe there's a typo when my students are actually typing this. So B and C is correct according to the composition of an atom. So you can change this to B, and that will be the answer. So the next question, time is not on my side. I am sorry, I have to rush you guys. Which of these is not applicable to Bohr's models of atomic structure? I've talked about this. Now we can talk about electron occupied restricted area core orbit is correct. I've talked about it. Energies are needed to absorb when moving from when energy is applied in form of photons or by collision. Photons is what you need. Energy can also move from what? From higher to lower. You know that. When that is to say energy is released, note that the energy is absorbed when you supply photons to it. So this is also correct. We know they move from one point to another. An atom with single electron can occupy orbit is only for hydrogenous. This is correct. But and does not migrate. It is correct. The permitted orbit are those with angular momentum with an integral multiple of you can see h over 2 pi. So please, where p is the momentum, I've talked about this, you can remember that. So definitely this will be the answer to the question, as number of electrons per atom is constant, is not in Bohr's atomic model. So please, if you understand concepts, questions are going to be easy. The next one, which of the following is not correct about Rutherford model of an atom? Rutherford, we've talked about that. I told you about what he discovered. The mass of an atom is concentrated in the nucleus, absolutely correct. Now, the nucleus of an atom is positively charged, absolutely correct. I've talked about the nucleus is surrounded by electron, absolutely correct. The model is applicable to atom with only one electron, that is not Rutherford, that is what Bohr's. So this is the answer to the question, my dear student. You can see the way we are doing it, and this is the way we do almost the academy. So please, the next question. Now, shorty question now. Neutrons were discovered by, I told you, I think I talked about it, James Chadwick. The electron was discovered by Sir J.J. Thomson. So you can see the way we are doing it now. The next question, still on Bohr atomic model, atomic structure, one of the simplest aspects. Bohr's atomic model proved most successful for the explanation of structure of an hydrogen atom. Absolutely correct. Line spectra, all the hypotheses, all the postulates are three. And I never talk about multi-electron system because it's for what? Single electron system, hydrogenic atom. So this is wrong. Correct answer, my dear, is Roman figure 1 and Roman figure 2. And that is option C, question answer. I hope students are getting this. I hope you are getting this. And please watch the video to the end for you to have a deep understanding of all this. Next question. The net charge on the atom is 0 before. The total, I told you, the total charge of an atom is always 0. Because the electrons and protons are charged in the, that are charged. Are charged in the nucleus. Electron is not in the nucleus. You know, electrons from nuclear physics are found outside the nucleus. The total charge of an electron is equal to the total charge of a neutron. Charge of an electron is not equal to charge of a neutron. You can calculate that from the formula I gave to you. Simple. The neutron forms a shield around the charged electron. That is the law. That is the answer. Very correct. Neutron is forming a shield around the electron because it is revolving around it. So the number of electrons in an atom is known. The number of electrons is equal to the number of protons. Please note that. So this is wrong. A and B is also wrong. So the answer is that, as we've talked about Rutherford experiment, and that is how we're able to pick the answer. I hope you are following. The next one, my dear student, in which of the following transition is the largest quantum energy liberated by an hydrogen atom when an electron changes energy level, where n is a quantum number? Now, I've given you formula for energy level. You can use it. It's equals to negative 13.6 multiplied by z squared by n squared. So where z is always 1, keep it at the back. You can start calculating and see the one that will transit. I told you, when they move from higher to lower, they become unstable. So the ground state is more stable than the excited state. Keep it in mind. So start substituting. When n is 1, z is always 1, get your answer. So look at the one there, but the logic is very simple. As they move from what, they are coming back, what we call, now I told you, when they move from lower to an higher, we talk about transition, and in that case we talk about excitation energy. There's also what called de-excitation energy. So there are a lot of things I can still tell you. The excitation energy means it is moving from higher back to lower, and when they are doing that, the highest what, they have the largest amount of energy that is being liberated. Energy is absorbed when you are moving from lower to higher. I think that is better, simple way. But when you are moving back from what, higher to lower, energy is liberated. So the answer to this will be from higher to lower. Definitely, it won't be from lower to higher. So you can cancel this because of liberation. Now look at this, 2 to 1 and 3 to 2. The answer should be 2 to 1. Why is it 2 to 1? You can substitute. When n is 2, get the answer. Z is also always 1. And when n is 1, look at the values. And when n is 3 and when n is 2, you are going to say more energy is what is given out in this than what. As you move from, like I told you, 2 to 1 liberate more energy than 3 to 2. That's the way it is. 3 to 2 will liberate from more than what, 4 to 3. So this is the way we calculate because of stability of them. Stability is what at lower than what at higher. Always keep that at the back of your mind. So guys, let's go to the last section. I believe it is the last. Absolutely should be. Now in the model of hydrogen atom, the energy levels Wn are given by the formula of Wn equals to R negative r over n squared, where n is a set of integers and r is constant. Determine the energy level from 3 to 2 when n is 3. Let's do simple maths. Wn will be equal to, I think this is negative r, for your level is very simple, over n is 3, that's 3 squared, that is 9. Then this is W3 now, W2 will now be equal to negative r over 2 squared is 4. What do I know? I was asked to find the energy released. So if I'm looking for energy released, you and I know I'm going to subtract the value. It is moving from 3 to 2, that is negative r over 9 minus, that's minus, that is plus, you know what I mean, r over 4. LCM, you can do that, is 36. This is 9 times 4, negative 4r plus 9r. That is 5r over 36, which will be the question answer. I hope you understand what I've done. Energy level, change in energy level is always equals to Hc over lambda, or you say Hf, always keep it in mind, which is always delta E1 minus delta E2. Now that's the last two set of questions. Maybe I should leave it for you guys to solve. More of nuclear physics, I guess. This is not written where helium should be 4-2, that is an alpha particle, which we are still going to talk about more under radioactivity. Then it's giving us how we write this. I will still talk about it because there is a way we write this when we talk about nuclear physics. There is a particular way this is being written. This is a very, very simple question. N is at 13.7. This X was bombarded with an alpha particle or helium particle, the way we call it. So, and it's giving us 13.7 from plus, we have a neutron, or it's this oxygen, I think it's 1, 0. So we just need to balance this. 13 plus 1 is 4, 7 plus 0 is 7, 14, 7. This is 4, 2. To get 14 from here should be 12. This is a simple stuff. And to get 7 here should be 5. I hope you understand that. I don't know what the question asked for, because this is 14 and 7. This is not 14. 12 plus 4 is not 14. 10 plus 4 should be 14. So 10 and 5, or 5 and 10 should be your answer, and this is the answer to that. So it's a direct question. Because of time, I just have to, because I still want to teach you how to calculate binding energy, especially for WAEC students. It's a simple form. I think maybe I should quickly talk about it, or what do you think? Then I leave this one for you guys to solve. The following symbolic representation is correct for an atom X with 22 electrons. We talk about electrons is number of protons, and 43 neutrons. You add to get atomic number 43 plus 22. I hope you still remember that. That's 65. So you look for what has this answer. We've talked about that, 6522, and that's answer to this question. So about the binding energy, there's always a way we always write it. It's simple. It's like more like the proton, or maybe I should leave it to the next class. The proton mass, for example, the proton mass, the mass of the proton, then we say plus the difference between, I'm considering X, Z, A. So the proton mass multiplied by the neutron, this neutron is A minus Z, multiplied by neutron mass, must give us the mass of X. So this is the formula we use, but for now, like I said, in my second video of modern physics, I'll still talk more about this. So always I said it's equals to minus that of what the element S itself. So this is the way we calculate binding energy, but we always give answer in terms of atomic mass units, which is AMU, and sometimes we leave it in terms of MeV, milli electron volt. So which is about 931.2, but it will be given. So I will do questions on that in the next video, don't worry, I promise you, because of WAEC students for theoretical questions. So this is just the beginning of the modern physics. Like I do say, if you find anything interesting in this video, consider subscribing. Thank you guys, and see you soon. Bye for now.